Laws of exponents rules. So now let's get right into the problems. So question number 1. To solve question number 1, you would square root 81, which would be equal to 9. For problem number 2, you would square root negative 9, and this is not a real number. No solution. To solve number 3, you would cube root 27, which is equal to negative 3. To solve number 4, since there's a negative sign right in front of the exponent, you would go 1 over 16 to positive 1/2, and that would be equal to 1 over the square root of 16, which is 4. So 1 over 4 is the final solution. For number 5, it's 9 over 3 to over 2. So then you would square root 9 and put that to the exponent of 3, which is 3 to the power of 3, which is equal to 27. For number 6, to solve this, you would cube root of 4 to 16 to the power of 3, and that would be negative 2 to the power of 3, which is equal to negative 8. For number 7, you would, since there's a negative exponent once again, you would go 1 over 8 to the positive 2/3, and that would be equal to 1 over 3 square root 8, and then square that, which is 1 over 2 to 2 squared, which is 1/4. For number 8, you would do the same problem as number 6. You would put 3 there of negative 27 this time to the 4th power, which is equal to negative 3 to the 4th, and that is equal to 81. And for number 9, you would solve it a bit different now. It would be 4 over 9, and each would be 3 over 2, 3 over 2. And then you would take it as a rule number 5 on the summary of the law of exponents, and this would be square root 4 over 3, and then square root 9 over 3, and that is 2 to the power of 3 and 3 to the power of 3, which is equal to 8 over 27. And for the last problem on our list, to solve this, you would first, since there's an x power base for all of them, you would add them up. 1 over 4 minus 1 over 2 plus 2/3. And this would be equal to, since we're looking for a common denominator of 12, and that would be, to do that, you would multiply 1 over 4 by 3, and then 1/2 by 6, and 2/3 by 4. So then you would get 3 over 12 minus 6 over 12 plus 8 over 12. And then that would be, first you would subtract, it would be negative 3 over 12 plus 8 over 12, and that is equal to 5/12. So the final solution is x to 5/12. Properties of exponential functions 3.4. These are the rules of exponential functions. Now let me show you the base function and its reciprocal. So the base function is y equals 2x. And for the x value, you just sub in for starting from negative 3 to positive 3. So let me show you how it is done. So negative 3, you sub in the value for x, and then since it's negative, you flip it so it's 1 over 2 to the third power, which is 1 over 8. And that's where I subbed in there. And for the reciprocal of the base function, it is flipped. So the negative numbers and the positive numbers are switched on the graph. A bacteria sample has a half-life of 3 days. The initial amount is 200 milligrams. So for problem number A, we have to write a function to relate to the amount remaining in time in days. So y equals a bx is the original equation, and to relate the time remaining with the amount remaining, we would do a t equals a o and r. AO is the initial amount, and R is the half-life, so that's 1/2. So the equation would be AT equals 200 1/2 T over 3. 3 is the amount of days. So the table of values would be, once you just keep subbing in each value for a t, we'll just fill it in over here. 158.74, 128.99, 100, 79.37, 63.0, and 50. So for the graph, since you see the numbers are going down gradually, the graph would start from 0 and 200 and keep going down as it goes along. So this exponential function is a decay since it is decreasing gradually at a steady rate. But the domain is always greater than 0 because it never touches 0. So x belongs to a real number such that x is greater than
related to transformations of exponential functions. So let's get right into it. So here, as you can see, we have an equation. From the previous part of the videos, you'll understand that an exponential function is usually y is equal to b to the power of x. That's a base function. In this case, now you can see there are a bunch of new letters, and we're going to talk about those letters. So in the first one is this a right here. The a represents vertical stretch or compression plus a reflection in the x-axis. It's a stretch if it's greater than 1. It's a compression if it's less than 1. And it's a reflection in the x-axis if there's a negative. So basically this will change the graph. It'll make it either longer, it'll make it longer, it'll make it shorter, or it'll make it go downwards instead of up. B is our base value. We already know about that. K, as you can see, is a horizontal stretch or compression and a reflection in the y-axis. So it's similar to A, except instead of talking about how long or short it'll get, now we're going to talk about how wide it'll be. And so in this case, it's a horizontal stretch if it's less than 1 but greater than 0, and it's a horizontal compression if it's greater than 1. And then it's a reflection again if it's negative. Now we have our D value. D is our horizontal translation. So this is how many units the graph will move to the left or the right. So as you can see, it's a minus, so it's flipped. So if it says -4, then that means it'll actually move to the right 4. And if it says +4, that means it'll move to the left 4. And then finally, we have our C value, which is our vertical translation, which will tell us how high or how low something should be. So let's start and get right into it. Right before I start, though, I just wanted to show something that if something is written as y is equal to 3 to the power of 3x, it's equivalent to y is equal to 27 to the power of x. So let's just start with our first question right here. It says, describe the transformations applied to the base function y is equal to 3x. So in this case, we have y is equal to -2 times 3x minus 3. So this will be our a value. So Since it's negative, it's going to be reflected in the x-axis, so that means it's going to be going downwards. It's 2, so it's going to be stretched. There is no k value or d value, and this negative 3 means that the graph is going to move down 3 units. Over here, we have y is equal to 3 to the power of 4, x minus 2 plus 3. Again, you could also write this as 3 to the power of, instead of 3 to the power of 4, you could write it as like what I did here, which is 81 to the power of x minus 2 plus 3. But basically, we have a k value of 4. So what that means is it's going to be by a factor of 1 over 4. That's going to be our k value, and it's going to be compressed. So it's not going to be as wide. X minus 2, meaning it's going to move to the right 2 units, and plus 3, it's going to move up. Let's move on to our next question. It says, write an equation for the function that results from the transformations applied to the base y is equal to 9x. So it says reflected in x-axis, stretched vertically by a factor of 2, and horizontally translated left 3 units. Reflected in x-axis, this means it's going to be negative, so y is equal to negative. Stretched vertically by a factor of 2, so it's going to be negative 2. And horizontally translated left 3 units. So it's going to be negative 2. I'm just going to put brackets around it. 9x translated left 3 units. So that means it's going to be x. X translated left would be plus 3. That would be our transformed. So I made this little question. It said, graph the base function y is equal to 4x and the transformed function y is equal to 4 to the power of 2 bracket x minus 1 bracket plus 1. So I set up 2 table of values, one for the base function y is equal to 4x and one for the other transformed function, and I subbed in the x values for x and solved it and wrote it down. And I just wanted to show you the difference in the tables. So here, this is just your regular function 1, 4, 16, 64, 256 to the power of 4. But over here you can see how it's 1.625, then 2, then 17, then 257. Look at, like, just look at here. For x, if x is equal to 3, y is going to equal 257. Over here, if x is equal to 3, y is going to equal 64. So what's happening right now is due to the 2 for the k value, this is all being horizontally compressed. So what that means is it's taking this chart over here would reach these values later. So you see how 4 over here, if x is equal to 4, y is equal to 4097. For this could also equal like 4096 or around there, but it'd have to be all the way around like 656. So the y values are getting higher while the x values are getting shorter, and that's why it's compressed. So over here you can see, I tried to graph it, but it's really big numbers. So you can see how this thicker line right here is y equals 4x, fair enough. And then this one is, you can see how it comes out a bit, the transformed one. And this is due to the compression, how it shoots straight up and it's going to keep going up. Whereas this one is slightly on a slant. The base function is slightly on a slant, while the transform function is going to shoot straight up and keep going because it's compressed. And when you compress something, if you have something like this, when you compress it, it's going to go like this. Similar shape, it's just squished. So that's what's happening. And that's it. That's all for 3.5. I hope you guys understand.